Hello and welcome to this video where we'll look at conditionals. And basically what we're looking at is if something is true or false. And later on you'll see about the if, and else as well. But this is just really looking at Booleans here and making comparisons. So the idea here, we've already looked at numbers and strings. We have these two data types. And as I've mentioned, there's obviously more than just these two data types. In fact, there's many others. But one that we'll look at here is called the Boolean. And it really does have a capital B because it's named after George Boole. And it was a branch of mathematics that was developed in the 1800s. And then they said, oh, hey, this works really well for computers. And they sort of borrowed it and became Boolean. But the key idea is that there can only be two values. Strings and integers, there's basically an infinite number. But in Boolean, the data type only has two. And it can be either true or false. Okay, so what you're basically looking at is using a comparison operator, so these inequalities that you're used to using in math, and being able to see if it's true or false. So the question here is 3 less than 8. That would evaluate to, oh good, I hear you all saying true. Yes, true. So that just checks to see, and then this whole thing here, right, which is sort of an expression, will evaluate to true. Okay? So like I said, these are the typical comparison operators, right? Less than, the opposite way is greater than. You can have less than or equal to. These are two separate characters, but as long as there's no space between them, it takes it as like one character, basically. Same with greater than or equal to. So less than and greater than, less than or equal to, greater than or equal to. And then you have the equal to, which I mentioned is not just one equal sign, it is two. And then this thing is a little bit different. The not equal. So that exclamation mark and an equal sign means not equal to. So if you were to solve this, and really what we're looking for is a true or false at the end, we have to evaluate 3 and 6, which would become 9, right? And then we compare 9 is less than 8. That is false, right? So that's what that comes out to. And you can work your way through all of these. Basically, you just do the math first. Check it out. So 3 is less than 5. Nope, right? And you just sort of work your way through. So 3 is less than 5, and then you can evaluate that too. Sorry, 3 is less than 5. Yes, it is. Okay, sorry about that. 3 is less than 5. That's true. So that's true. Let me redeem myself here. 12 divided by 6 is 2. So that's 2. 3. 2 is greater than 3. That one's false, right? Good. This one, right, 7 minus 3, I just need to prove myself now. 7 minus 3, I do the brackets first, which is 4. 4 times 3 is 12. So this is 12 is less than or equal to 10. I would say that's false. Good. And then this one here is 14 equal to 14. Last time I checked it was, so that would be true. Good. Okay, so the idea, I mean, you could put some, more realistic expressions here. So we've got what? Lives plus 4 is less than score minus 1. So I don't know why we're doing this, but that's what we've got here. So again, we would just put the values in. So this here is 5, just like we did before. So this would be 9. And then 9 is less than 9. That actually is false. So be a little careful there, right? So those both were valued to 9. And so that's false. Even they would be equal. If we did less than or equal to, that would be true. But because we said less than, it is false. Okay? So, right, it's going to evaluate to a true or false value. Can I go to the movies? I'm allowed to go if it's before 8. So we need to know the time. So we can put a little a variable called time, and then we could put it in. So we can have this kind of a flow chart here, where if we put the value in, we can evaluate it. And if it's true, we can go to the movies in this case. And then if it's false, we can't go to the movies. I don't think we can go to the movies at all at the moment. Okay, so it's 9 o'clock. You plug the number in, right? Then we make the evaluation. Okay, so is 9 less than 8? That's going to be false. So we end up going over here, and you unfortunately can't go to the movies. Okay, have I won the game? I have my score times my lives is greater than 10. So we take a look at that. I don't know what your score is. I don't know what the lives are. So we put some values in. So if we had 3 and 3, well, 3 times 3 is not greater than 10. 10 times 1 is not greater than 10. And then -5 times 2 is not. So I believe all of those would be false. And you run through those. Is my dog older than me if his age is converted to human years? So, obviously the same idea of the flow chart. You've got the age times 7, right? Then we just need to know the values, and we can put it in. Can I adopt a cat if I have $40 and I am over 14 years old? So in this case, you've got two things, right? So we'd have money and age, and in this case, we'd have to run through two separate stages, right? If you've got $40, now this is a little bit odd that you've got exactly $40, and your age is greater than 14, so you'd have to be 15 and so on, right? So if you're 17 and $39, well, this would be true, right? You're okay on the age, but unfortunately 39 does not equal 40, and so you can't adopt a cat, right? That's tragedy. That's a tragedy. Okay, everyone needs a cat. So there we go. Can't adopt a cat. Oh. Now you can see that we had to go through two separate stages. Well, there's something called the logical operators, which are and, or, and not, and they have kind of the two ampersands to represent and, the two, what do they call those? Now I've forgotten. But basically these two lines, vertical lines, that's the or, and we kind of saw this before, the exclamation mark refers to not. So true and false actually ends up being false. So we'll talk about that in a truth table. So basically the false sort of wins there. So we'll go through this. So let's take a look at these truth tables. If you're doing the and, in order for it to evaluate to true, both of these have to be true. So this has to be true, this expression has to be true, and this expression has to be true. If you have one false or both falses, the whole thing is false. Okay, so that's basically for and, both of them have to be true. The or is more permissive. If you have true or true, that's true. If you have true or false, that is true as well. So, and we'll practice these more, okay, but the idea here is that at least one of them being true will give you true. One or more being true will give you true. Okay, if both are false, then they both become false. So like it says here, either may be true for the Boolean expression to evaluate as true. Not is just the opposite, so not true is false, not false is true. Pretty straightforward. So instead of having those two separate steps, right, if we look here, $40 and I'm over 14 years old, we can put that in to one sort of expression, right? So the money is equal to $40 and the age is over 14. So if you're 15 years old and $40, ooh, good, we can get a cat here, right? Money is 40, age is 15. Both of those are true, so you can adopt a cat. Run through that. Both are true, therefore it values to true, and you can get the cat. Yay! Okay. Now you can make your own little thing, right? So you've got two variables, you can make it or, right? You can make it and, whatever it is, and then you end up with the two outcomes, depending if it becomes true or false, okay? So see if you can do that. I mean, it's a good idea to practice that. What's the situation, right? It could be about getting a job, it could be about getting a mark or something like that. Just over here, right? 10 is less than 2 evaluates to false because it's false. 4 is equal to 4, that's to true, right? In terms of the key takeaways here, right? A Boolean is a type that is either true or false, right? Type of data. Comparison operators, we looked at those, is the 6 comparison operators. Okay. Each side of the Boolean expression has to be reduced to a single value so you can make that comparison, right? And the single values are then compared and the result is either true or false, right? That Boolean value. We also talked about these ones where you've got the and or the or, right? So Boolean expressions can also include these logical operators, and, or, and not. Both sides of the logical operator are reduced to a single value, and then it is reduced to a, a single Boolean value itself. So, like I said, these truth tables, and they're pretty easy to remember, right? Those help you evaluate whether true and true, right? That evaluates to true. True and false, obviously, is false. False and true, just running through these, is false. And false is false. Right? On the other hand, the OR operator, right, it's more permissive. So true or false, false or true, those all evaluate to true, and only false or false evaluates to false. Right? But again, everything comes down to that single Boolean value once you've worked it through. Okay, and we looked at those flowcharts, right, that illustrate the steps for making that decision with the Boolean expression. So you can draw it out. What are the conditions? Is it going to become out true or false? And you can get something a bit more complicated, right? You could have multiple levels of decisions being made as your program goes through. Good. So that's it for conditions. So try those. This really just looks at the, like I said, the Boolean. The idea of flowcharts are there. And later on, the if, else if, and else will sort of help you make your programs a little bit more complex.